Hi there. I would like to present our work on SIMEase, which is to use visual programming to support the easy creation and validation of stateful analytics. This is joint work done by a group of researchers from Conviva, the University of Illinois at Urbana-Champaign, and Carnegie Mellon University. First, what is stateful analytics or stateful metrics? So I will be using these two terms interchangeably in this talk. A simple working definition of stateful metrics is that the output of such metrics depends on a sequence of events across one or more input streams. So this might sound abstract, so I'm going to give you a concrete example shortly. At Conviva, we observed that many of our real-world customers really care about stateful metrics. For instance, they like to create such metrics to monitor the performance of real-time streaming systems. So let me give you a toy example. This is a fitness tracker. In this particular dataset, as the table shows, we have many measurements, such as stress level, the activity a user is engaging in, the sleep status, VO2 stands for oxygen consumption, and heart rate. These are all timestamped. Perhaps an easier way to visualize this dataset is by using what we call a timeline preview. So in this case, you see that the stress level changes as time goes by, and same as the activity. So first, let me give you an example of what is a stateless metric. So a simple example could be the average value of stress measurements. So in this case, all we care about is just the stress measurements here, regardless when the measurements were taken, you simply take the average, and that's your average value. In comparison, for stateful metrics, here I have another example. How long was I in high stress while working? In order to answer this particular metric, you first have to deal with multiple input streams, both the stress level as well as the activity. And not only that, you have to actually calculate the duration for this person that satisfies both conditions. You might wonder, what is the current status in terms of creating such stateful metrics? Well, typically people have to create SQL query in order to calculate such metric. And this is what we did for this particular example. As you can see, that this is actually quite complicated, and it took a while for us to actually create and validate this particular SQL query. Instead, what we propose in this work is a visual programming platform, which we call SIMEase. And here I'm showing you a diagram. This is essentially the visual representation using our tool to generate the exact same stateful metric that we saw earlier. And as you can see, there's no single line of code. Everything is visual. So this is really the idea of visual programming. Before I dive into the tool, let me tell you a little bit about the design process that we used to actually create this tool. So we started with a foundational user study where we interviewed 6 practitioners, and we were curious about their current practices and their challenges and needs in creating and maintaining stateful metrics. Next, based on these insights, we created low fidelity prototype, and then we went back to those practitioners and get their feedback. We improved the prototype, and then we turn it into a functional high fidelity prototype. With that, we did 2 rounds of formative user evaluation with 11 additional practitioners, and we got lots of feedback. Again, we improved the prototype based on their feedback. And finally, we conducted a summative user evaluation in the form of case study with another set of 20 practitioners. I should say that one limitation of this study process is that all these practitioners in our study were from the same institution, same company, Conviva. However, they came from different backgrounds and job roles. There were software engineers, data scientists, as well as project managers and customer representatives. So this is a high-level overview of this tool, SIMEase, which stands for Stateful Event Analytics Made Easy. On the left-hand side of this UI, you see a node operator library. So this is a set of operators that users can use to transform the data stream in order to create a data pipeline that would eventually calculate the intended stateful metric. And the window in the middle is the node graph editor. So a user can drag and drop operators from the left-hand side into this canvas or editor, and then connect these different boxes using edges, and then eventually create a graph that will calculate the value for this intended stateful metric. And finally, on the right-hand side, we have node setting specification window where a user can configure certain settings about this particular metric. For instance, giving a user-friendly name of this metric. So now let me give you a quick video demo of how the system works from an end user's point of view.
This serves as the initial landing page when users log into our tool. It provides users with a clear pathway to grasp the metric creation process. Here, they can easily access a template that guides them through the steps required to build a metric, with concise explanations attached to each node. To gain insights into each step, users can simply click the arrow associated with any node to preview the outcome of that specific step. On the left-hand side panel, there's a comprehensive list of operators. Hovering over these operators triggers an animated tooltip, which aids users in comprehending the core concepts behind each operator. When users are prepared to embark on creating their own metric, they can do so effortlessly by clicking on New Metric and clicking Adding a New Dataset. Upon clicking Adding a New Dataset, a dataset node populates the interface. Users can then proceed to click Import File to bring in a local dataset. Let's take an example. Suppose we have fitness data. Note, the data stems from a single workout session from an individual. Imagine you want to determine the duration this person spent in the aerobic heart rate zone, 150 BPM or higher, while running. Begin by clicking the arrow to preview the dataset initially. Once you've done that, close the preview and conveniently choose the operator you wish to employ by hovering over the respective node. In this case, select Get State and specify the dimension as heart rate. Then, opt for greater than equal to filter the heart rate range you wish to analyze. Subsequently, pick a new Get State operator, setting it to running. Select an AND operation to combine the two timelines. Up to this point, the timeline primarily consists of a Boolean state. To calculate the duration when the state is true, select Duration True. Lastly, select Make the Metric to generate a numeric metric. This process illustrates how to construct a metric for determining the duration an individual spends in the aerobic heart rate zone while running.
Now I want to talk a little bit about what's under the hood. So we built SIMEase on top of the timeline framework, which is our prior work that was published at Data Research System Conference last year. At the core of this framework is a set of operators. So as we saw earlier, these operators are things that the user could use to transform the data stream. So the set of operators consists of both some traditional operators that we're already familiar with from essentially any programming languages. You have logic, arithmetic, and comparison operators. But we also have some novel operators created just for expediting the creation and validation of stateful metrics. So these are extract operators such as getState, getEvent, as well as stateful model operators such as hasBeenTrue. I won't go into the details of the semantics of these operators, but you can find the details in the paper. Let me also briefly talk about the system implementation. Obviously, in the video demo, we saw the front-end UI. As user create this graph, whenever they click a particular node in the graph, they want to see, the underlying data or the timeline preview, the front-end will send a request to the backend, which we call the TOB backend. It stands for timeline backend. The timeline backend was written in Rust, and it's very performant. It's more performant than most of the existing streaming systems in the industry. Finally, let me talk about the case study. So we had 3 real-world use cases that we observed from our customers at Conviva, and we created 3 data sets, 1 for each scenario. So there are video streaming, there's site browsing, and there's fitness tracking. So for every one of those 20 practitioners in this final case study, we randomly assign one of the 3 data sets to each participant, and we ask them to create a stateful metric using our tool. And then after that, we want them to compare how they would do it using SQL. And finally, we finished with an exit interview about their experience using the tool. I won't have time to talk about all the nitty-gritty details from the results, but here I'll focus on some of the high-level takeaways. First, our participants found CMEs to be more intuitive and less time-consuming compared to SQL. So here's one quote. "It is graphical, so very intuitive. It would be a good tool for non-technical people." So remember the SQL query show is actually quite complicated and takes a long time to create, whereas in CMEs, they don't need to write a single line of code. All they need to do is to create this graph using these boxes and edges. And when we created CMEs, we had the goal that it should not only support technical roles such as software engineers, data scientists, you should also give folks who are less technical a way to create stateful metrics, such as project managers or customer service representatives. Here's another quote. "SQL will take more time to validate, and it misses some of the auto-suggest for operation. As you saw in the video demo, we created this auto-suggest feature to automatically suggest what would be the next node or operator for this data pipeline, according to the compatibility between among these different operators." We also ask our participants to rate and compare both CMEs and SQL in terms of creating stateful metrics along 5 dimensions. So first, to what extent do they feel they can collaborate with the tool in creating the stateful metric? And 2, do they feel they're in control using the tool to create metrics? And 3rd, were they happy or satisfied with the final outcome of the stateful metrics they created? And 4th, does the tool help them think through the process in creating this stateful metric? And lastly, to what extent the tool is transparent in explaining how it arrives at the final stateful metric? So as you can observe from this graph, across the board, CMEs was rated higher than the SQL approach. And oftentimes, the difference is statistically significant. So with that, I would like to thank our participants for sharing their insights. We also would like to thank our colleagues who have given us a lot of inspirations and also support in creating this tool. And finally, we want to thank the thoughtful feedback from our anonymous reviewers in making this a stronger paper. Lastly, let me briefly summarize the takeaways. So stateful metrics or stateful analytics is key for business outcomes in many domains, as we observe in Conviva. And today, writing stateful metrics in existing frameworks is very tedious, error-prone, and requires significant program expertise. So as we saw in that SQL query example, our work aims to democratize stateful metrics using the visual programming